Hello and welcome back. Boxing Day here in not so sunny Lincolnshire, UK, 2021. 6v6 amp. Apologies for the other day, the Christmas video. I was absolutely dog tired. I'd had enough. I'd been standing up for about a week on legs that shouldn't be stood up on, which I'm doing again the same thing. I'm not in bed. I'm a sucker for punishment, so yeah, apologies about that. Anywho, while I was mucking about filming that video and testing and things, I touched one of the output transformers and got a belt. What the frick? What's that about? A belt? By a belt I mean an electric shock. Not the last, not the first, sorry, not the last probably. Anywho, I was thinking, what's that all about? So I took all the probes off and everything, turned it upside down, powered it up, put some music in one end, nothing coming out the other. What is going on? So I thought, right, make sure there's, a wire's not falling off. Check the HT. No HT. What the bloody hell? I've been checking the DC conditions. And then I looked. I'll put my fag down so I don't keep wafting that around. And I hadn't soldered a wire from the ground of the power supply caps to the main grounds bus. So how it was working I don't know. The speakers were grounded to the but that was it. So somehow either, this is my theory, either because I had two digital meters on the amplifier testing it, either it was grounding itself to the ground bus through the meter, or it was this bus over here was being grounded somehow through the output transformers. But that would imply a leakage between the secondary and the primary. I don't know, I can't figure that one out. But I'm not going to waste time thinking about it too much. So anyway, ground duly soldered in. We've got two problems. Well, we've got a few problems. Sorry, two faults. Yeah, not that one. Two faults that I've found. We've got a hum when the volume is turned up that changes. I don't think you can hear it on this bloody microphone or this camera, but it changes as you go past the sort of 12 o'clock position. So that means our impedance, input impedance is changing that somehow. I think it's 100 Hertz, pretty sure it's 100 Hertz. Twiddling all the different humbuckers does nothing. And the other thing we've got is, you'll notice, we've got one output, sorry, we've got one input in, the other one is grounded. However, we've got an output coming on that. You see over here, look. That's the channel that it's going into. Right, this is interesting. I've basically pulled that ground wire off that bus, but we're still getting a signal through. So somehow the signal is coming in through the input and it's still getting through, which is weird because it's got no ground, it's floating. I've got a jumper here, sorry you can see, crocodile clips going to that screen of that screen lead, and if I clip it onto here it diminishes. It's still there but less so. So I think we've got a ground problem there. It may even be coming through to the chassis through those two RCA things there that should be insulated from the chassis, so that's something to look at. I'm going to look at that now. Right, I've pulled that ground bus here off that connection that goes to the valve socket which goes to chassis, and I've got one end of my probe here on the ground bus, and this is the other end of the probe, meter on continuity. So somehow that ground bus is getting to the chassis, but it shouldn't be. It shouldn't be connected to the chassis. So it's either connecting to the chassis over here, here, or I suspect these RCA sockets. So I'm going to have to pull that sort of wire off there and then test each of those RCA sockets. I did drill the holes bigger and then put some shrink sleeve around the bodies of the RCAs, because they haven't got like a plastic insert that, you know, keeps them away from the chassis. So as suspected, one of these is grounded when it shouldn't be. So the ground, right, right, as suspected, one of these RCAs, the ground lug is touching the chassis. I've got one probe on the chassis, and there's my other probe tip. That one's good, that one isn't. Right, this is the sort of weird trap you end up in if you're not careful. That's showing continuity from that RCA ground tag to chassis. Right, we agreed there. Now watch. What the? So what is that all about? That scope lead goes from there, that scope goes through the screen of that to this BNC to earth. That is a reference to mains earth, right? But then and again, so should this input be. It's not floating, look. That's floating. That is reference to mains earth. So that it isn't, this RCA ground lug isn't going to the chassis. But if I do that, put the input in, I'll take that off, stop it buzzing. So if that input is in, then it's going from there through the shield of this output of the HP 8903B audio analyzer to mains earth, to this mains earth, because this scope is mains earth, and back over to here. But then this ground bus here isn't going to the chassis, but this is saying it is. This is getting more confusing just when you think you're getting somewhere. Right, so look, it isn't. I know it damn well isn't. Right, more investigation is needed. Right, so I'm pretty confident how the ground bus was getting connected to the chassis. It's from this pot here, which, as you can see, has got a metal tab which then goes to the body of the pot, and so we didn't need this ground here. That's got to come off, so that would be causing one ground loop through the chassis and then back to that ground there. So I'll try and sort all our grounds out, chassis grounds and whatnot, and then we'll see if the problem still remains. But that is a something to watch out for. Ground loops and earth loops through your test equipment. It's a bugger. That's why a lot of people like take the earth off the scope and things like that. I mean, especially when you're probing switch mode power supplies and things like that that have got no isolation transformer. But yeah, you've got to be careful with this shit because it can kill. Anyway, let's see if I've stopped the fault. Well, that's all the sort of hidden ground faults I've found around here, but we're still getting bleeding between channels, however it's less, and we've still got some hum, so we're not there yet. There we are, another day looking at this amplifier, and it's got two main faults, as already mentioned. It's humming, and we've got crosstalk. I've been reading up on this subject online, and there's not a great deal about it, only to say there was a DIY audio article about possible crosstalk between anodes in a double triode. I don't think that's what we've got here. I think what I've got here is a grounding problem, and so I think the two things are caused by the same problem, which is the grounding problem. Mainly I think it's to do with this shield, but there's a few things we can try. Before that, let's turn this off and have a look here. So this is sort of what we got going off yesterday. We've got, this is our signal source, in this case my HP 8903B audio analyzer. There's the positive part of the signal going in there, and the ground going to sort of a ground. This goes into a 250k potentiometer, part of a balance pot, a dual gang balance pot, goes into a 1 meg potentiometer, which then goes into a 6SL7 control grid. I've not drawn any of the resistors or anything of that nature. I'm just interested in the grounds. As you see, our ground from our signal source basically goes into our input there, that's our RCA there, and this is the screen cable here. We're using the screen as that ground connection, and then that in turn, should I say, should go to the ground bus. Right, there's one missing there, one moment. I've drawn that in. I don't know why I missed that before. I think I forgot to pen it in. So that's our screen of our screened cable going to this ground bus. This ground bus is this one here, down there. Now then, also we add basically a ground loop. This is the chassis connection, so that ground bus is grounded there to the chassis, right near that socket. But also we had a ground loop like this, in that this pot here was also contacting the chassis, and this pot was also contacting the chassis. So we've got a definite ground loop there. If you want to find a lot more about ground loops and things of that nature, I will link in an article on this video in the description for you to have a look at. It's a very interesting read. It's quite a it's quite a complex subject, really. It's not as straightforward as it looks. The other thing is that we had was like an earth loop, and these are basically our sort of three sort of devices connected together. This is the HP 8903B, our amplifier, and our oscilloscope. All of those, apart from the amplifier, are connected by a mains earth loop there. But that's also sort of goes through the amplifier through the screen cable of the signal inputs going through the amplifier. Combine it with that, we end up with all sorts of crazy problems. So what can we do? The first thing I'm going to do is to try to lift, find my pointy stick again. First thing I'm going to do is to try to lift this ground here, this this screened cable there, and instead of the signal going through that cable like that to there, I'm just going to put a jumper from there to there and then see if that works. Let's try that. Well, that didn't fix it. We've still got a problem there. Okay, that was interesting. I just tried that off camera. I've got to be really careful here because we've got high voltage down here, and this is basically what this is just a piece of aluminium scrap sheet going to the ground bus. I've got to be careful here. You won't hear it, but I can hear a difference if I put that between the transformer and the 6SL7 circuitry. I can definitely hear a difference. So maybe that's something to look into as well as far as the buzzing is concerned. So the buzzing is basically being induced into these wires. These wires are acting like antennas here, and so all this sort of magnetic flux coming off the transformer is getting into these wires, making it hum. Pretty straightforward there. I'm still not quite certain about this crosstalk, so I'm going to do some more work on that. Right, I've stuck a highly sort of DIY alien hat on the transformer to stop any cosmic rays from getting in its brain sort of network. Well, no, actually what I've done is I've put a Faraday cage around it, or a magnetic flux band, or one of those other complicated sounding what do you call it, sentences. Anyway, put that round there to try and act as some sort of flux band. Got no copper tape, no real difference. However, if I then get our what do you call it, jump lead that goes to our ground and touch that, that stops the hum. So the next thing then is to try and find out how this bloody crosstalk is getting in there. So the first thing to try is to try a different valve. Is it the valve that's somehow, you know, is the signal from one triode jumping across to the other one? We'll try that. Okay, we've replaced our 6SL7 with a 6SN7. No improvement. Right, more thinking. Okay, I tried replacing the dummy load wiring with just a free sort of standing load resistor on the output of the other channel, just to see if that was how it was somehow getting crossed over. It isn't. We'll try something else. Okay, I tried decoupling the screen grid from the other channel, wondering if somehow the signal was getting cross-coupled through that screen grid supply. I don't think it is. So now really the only thing to do is to get the scope out and try and scope. Use the scope to probe the input and what have you, to try and find out where the signal is getting cross-coupled. In a nutshell, it's either getting cross-coupled by some wire or some connection, like a direct connection. A mistake I've made or something like that with the leads or something of that nature, or it's getting cross-coupled capacitively. As mentioned, it is possible for a signal to jump across from anode to anode in a double triode by the capacitance between those two anodes or other parts of other electrodes. Could it be done inductively? I don't know about that. I think I've discounted that by using a different load on the output on one channel. But could it be getting coupled from one output transformer to the other inductively? I don't think so. Not at that level. Not at the level it is. If it was really small, maybe. So it's either capacitively, or we've got a connection between, let's say, the pot or something like that. I don't know. I'm going to go through with my meter first, and I'm going to try the scope, see if we can find out where it's getting cross-coupled. Well, here we are, another blinking day. Totally took out all the pots, and we're just going simple as possible. So we've got two separate wires, two separate screen grid wire, two separate wires going to the two control grids of the 6SL7. That didn't cure it. So then what I did, I decoupled separately each anode of the 6L7. As you can hear, still got an output when there shouldn't be one, and that's the control grid of the 6SL7 that shouldn't have any signal on it at all. Here we are 1 week later, after finding that we've got a crosstalk problem with this amplifier. Somehow we've got a leakage of the signal from one grid to another. I have tried decoupling the anode resistors where they were a shared decoupling before, now decoupled one each individually. I've tried testing whether the leakage is the valve, whether it's somehow going through the ground. What else have we tried? I've tried loads of different things. I've tried testing whether it's somehow leaking from output transformer to output transformer and then back, or something silly like that. Well, I've tested using different cable, screen cable, to see if it was being capacitively coupled between the cable. It isn't. I've tried everything I can think of. The only thing remaining is the valve base. If you look, there's some sort of conformal coated yellow stuff. Whether that is acting as a pathway, I do not know. I've just tried, with the amplifier off, I've just tried putting a signal here on one grid and then putting a scope probe here on the other. However, those are not the same sort of conditions that exist when this amp is powered up. When the amp is powered up, there's a very high impedance here, and obviously there's more stray capacitances. I don't know. I'm floundering. I'm really at a loss as to what is happening here. So I'm going to try changing the valve base and see if that works. Well, I'm scunnered. I'm absolutely bloody scunnered. Changed the valve base, still got the problem. So that is one of the, let's see if I can get this. This is a bit iffy, this. Right. That is the opposite triode's grid. Shouldn't be any signal on it. That grid is grounded with a grounding plug. And there it is on its grid, and then away it goes into the 6v6 output stage and speaker. However, watch this. I'll put you near the speaker so you can hear this. Right, watch. That is changing. Me putting that scope probe in there is changing it. So we're back to this grounding issue. See, at the moment this is powered up for a Variac with no earth, no mains earth. Let's see if that makes any difference. I mean, I'm just guessing here. See if that makes any difference whatsoever. Any ideas? I'm bloody lost. I really am. Yeah, I know I keep saying it, but I'm... Right, well, it's no good me just sitting here rambling. I don't know. I've tried everything. Does it matter? Yes, it does. It shouldn't be doing it. When you play music through it, it doesn't really make any difference, but... I'm going to ignore it for now, or have a think. I don't know. Fuck knows. Fuck knows. And that is freaking swearing. No idea. Well, after a week of trying to fix this crosstalk fault, I've had enough. I'm just getting nowhere. I'm going round and round in circles, and so I've popped it over there. Up your frigging pipe, you bastard! Calm down, calm down. So yes, it's relegated to the shelf of shame. You try saying that. And in the meantime, I will do some work on this Tech 7704A, which has a few issues. Video coming out soon. Some things, I don't know, some problems just get you beat and you just have to put them away and walk away and just come back to them later with a fresh sort of, I don't know, I've asked folk on forum for their ideas, and yeah, I've apart from changing the valve base and decoupling the two anodes of the 6SL7, that's the only suggestions they've come up with so far. So yeah, away you go. I'm going to do something else for a bit. So thank you very much for sticking through this interminable video. Take care of yourselves, and ta-da for now.